It's 1970, and aviation is at its turning point. Boeing's giant 747 is stealing headlines, but for most airlines, it's simply too much airplane, too many seats, too much fuel, too much risk. Airlines need something smaller, leaner, but still revolutionary. McDonnell Douglas promised exactly that. Their DC-10 would bring wide-body comfort, free, powerful engines, and lower operating costs. It was pitched as the jet that would outsmart Boeing and crush Lockheed's rival TriStar. This was supposed to be McDonnell Douglas's crowning achievement. Instead, it became one of aviation's darkest cautionary tales. This is the story of the DC-10, the jet that promised everything, delivered tragedy, and changed the skies forever. The story begins in 1967. The Boeing 747 is about to make its debut, and the world is watching. A giant that can carry 400 passengers, but at a staggering cost. Airlines are skeptical. Most look at the 747 and think the same thing. We need something smaller. The race is on to build the perfect wide body, bigger than a narrow body, but far more efficient than the 747. Two main contenders step forward. Lockheed, with its elegant L-1011 TriStar, and McDonnell Douglas with the DC-10. McDonnell Douglas makes a bold strategic gamble while rivals experiment with twin-engine designs. They chose three. Why? Because in the 1970s, ETOPS was a massive roadblock. Lose one engine on a twin, and you might not make it to an alternate airport. Regulators, they wouldn't allow those jets to cross oceans or fly certain remote routes. But not everyone agreed. In Europe, a new consortium called Airbus was quietly working on the A300, the world's first twin-engine widebody. At the time, most airlines dismissed it. With ETOPS restrictions in place, a twin jet seemed like a dead end for long-haul flying. But in the long run, it would prove to be the shape of things to come. For McDonnell Douglas, 3 engines were the sweet spot. Enough redundancy to fly almost anywhere, but still more efficient than a 4-engine jumbo. The DC-10's trijet promised the holy grail: lower fuel burn than the 747, more range than a twin, and freedom to serve nearly any route on Earth. For airlines, it was just right. American Airlines became the launch customer, ordering 25 DC-10s for transcontinental routes. United quickly followed with 30, Continental with 15. These weren't just purchases, they were bets on the future of aviation. McDonnell Douglas moved at breakneck speed from American's initial request in 1967 to first flight in 1970 to passenger service in 1971. Just 4 years. That aggressive timeline, it put enormous pressure on Boeing, and it forced Lockheed to rush its competing TriStar. And here's a detail most people miss: the DC-10's cargo hold. McDonnell Douglas designed it to be unusually spacious, maximizing revenue potential for airlines. At the time, it looked like a clever advantage. Later, it would prove catastrophic. By 1973, the DC-10 had become the backbone of long-haul fleets worldwide. KLM flew them across the Atlantic, Japan Airlines across the Pacific, Swiss Air throughout Europe. McDonnell Douglas believed the DC-10 would cement their dominance over Boeing and Lockheed and establish them as the world's premier aircraft manufacturer. The future looked limitless, but revolutionary aircraft demand revolutionary solutions. And some solutions, they come with hidden dangers. Most aircraft cargo doors open inward, held shut by cabin pressure. It's a natural fail-safe design. The DC-10 doors, they open outward to maximize that valuable cargo space airlines love. This outward opening design demands a foolproof locking mechanism. Latches and pins must withstand enormous pressure differences at cruising altitude. If this system fails, explosive decompression could destroy the aircraft in seconds. Enter Dan Applegate. This McDonnell Douglas engineer, he understood the physics of the door better than anyone. In 1971, he wrote an internal memo that should have stopped everything. The cargo door locking mechanism, he warns, is dangerously unreliable. His words are prophetic. If the door blows out, explosive decompression will collapse the cabin floor and sever critical flight control cables. But corporate culture reveals its true nature. Applegate's memo disappears into company bureaucracy. McDonnell Douglas is hemorrhaging money, racing to capture market share from Boeing and Lockheed. The L-1011 is breathing down their necks. Orders are at stake. Redesigning the door system. That would mean catastrophic delays. Cost and schedule pressures win. Safety concerns lose. Then reality intrudes. American Airlines Flight 96 at DC-10 departing Detroit for Buffalo, with 67 people on board. Climbing through 11,000 feet, when Applegate's nightmare becomes real, the cargo door blows out with explosive force. The cabin floor partially collapses, jamming flight controls exactly as Applegate predicted. Captain Bryce McCormack and his crew fight compromised systems, nursing the crippled DC-10 back to Detroit Metro Airport. Their airmanship saves every life aboard. The NTSB investigates and confirms the obvious. The cargo door latch mechanism failed catastrophically. This should trigger immediate design changes across entire DC-10 fleet. Instead, McDonnell Douglas implements what they call fixes. They install small viewing windows so ground crews can peek inside to check if doors are properly latched. They strengthen vent valves and issue advisory bulletins. But these are suggestions, not mandates. The fundamental flaw Applegate identified, it remains unchanged. For nearly 2 years, hundreds of DC-10s continue flying with this known vulnerability. Airlines perform inspections. Crews check the little windows. But the underlying design defect stays exactly the same. The aviation industry is playing Russian roulette at 38,000 feet. And somewhere in the world, another DC-10 cargo door is waiting to fail. March 3, 1974, Turkish Airlines Flight 981 pushes back from Paris-Orly Airport on a Sunday morning. On board are 346 passengers and crew. The flight had originated in Istanbul and was scheduled to continue on to its final destination, London, with Paris as a planned stop along the way. A common practice at the time, it should have been a routine 90-minute flight. In the cargo hold, a Turkish Airlines ground crew member struggles with the DC-10's complex door mechanism. The latches appear closed. The viewing window looks normal, but the locking pins, they're slightly misaligned. It's exactly the scenario Dan Applegate warned about 3 years earlier. Flight 981 climbs normally through French airspace. 13 minutes after takeoff, at 23,000 feet, physics takes over. The pressure differential overwhelms the misaligned latches. The cargo door explodes outward into the slipstream. Unlike Flight 96's partial floor collapse, this failure is total. The cabin floor pancakes downward, severing hydraulic lines, flight control cables, and electrical systems. The pilots lose all control inputs. The DC-10 becomes an uncontrollable projectile. 6 minutes later, Flight 981 impacts the Amanville forest in France. The destruction is absolute. No survivors among the 346 souls aboard. At the time, it's the deadliest aviation accident in history. The global aviation industry reels in shock. Death Jet and Flying Coffin dominate headlines from London to Tokyo. Passengers worldwide refuse to board DC-10s. Travel agents report that up to 30% of passengers specifically request no DC-10s when booking flights. Some airlines quietly begin referring to DC-10s by flight number only in announcements, avoiding mention of the aircraft type. French investigators quickly identify the cause. The same cargo door floor that nearly destroyed Flight 96. Dan Applegate's buried memo resurfaces, its warnings now tragically vindicated. The engineer who tried to prevent this massacre becomes a symbol of corporate whistleblowing and the deadly cost of ignoring safety concerns. For McDonnell Douglas, the incident is potentially catastrophic. Stock prices plummet, orders are canceled. Their reputation as a safety-conscious manufacturer lies in ruins. The company that believed the DC-10 would secure their dominance now fights for survival. But this is just the beginning of the DC-10's troubles. McDonnell Douglas then scrambles to fix the cargo door problem. They completely redesign the system with redundant latches, backup systems, and cockpit warning lights. By late 1974, the DC-10 returned to service with genuinely improved safety systems. But public confidence is shattered beyond repair. The death jet stigma proves nearly impossible to overcome, despite genuine safety improvements. Then disaster strikes again. May 25, 1979, American Airlines Flight 91, a DC-10 bound for Los Angeles, begins its takeoff roll from Chicago O'Hare on a clear Friday afternoon. 271 people aboard, trusting the aircraft's rebuilt reputation. During the initial climb, witnesses watch in horror as something impossible happens. The left engine separates completely from the wing. The massive General Electric CF6 engine, weighing 12,000 pounds, tumbles across the runway as the DC-10 continues climbing. But the aircraft is now fatally damaged. The engine system severs hydraulic lines controlling the wing's leading-edge slats. On the damaged left wing, slats retract, while on the right wing, slats remain extended. This creates a catastrophic aerodynamic imbalance. The DC-10 banks left, stalls, and rolls inverted. 31 seconds after engine separation, Flight 191 crashes into an open field near the airport. All 271 aboard perish, plus 2 on the ground. It became the deadliest aviation accident in U.S. history, a grim record it holds to this day. The investigation reveals that American Airlines used an unauthorized maintenance shortcut. Maintenance engineers removed the engine and pylon as a single unit with a forklift instead of following proper procedures. This time-saving method created microscopic stress fractures that led to catastrophic structural failure. While this accident was caused by maintenance errors rather than design flaws, the public makes no such distinctions. Following the incident, every U.S.-operated DC-10 is grounded. By late 1979, the DC-10 had been involved in 3 fatal accidents within 6 years, an unprecedented rate for a modern airliner. Airlines lose confidence not just in the aircraft, but in McDonnell Douglas itself. Orders for new DC-10s evaporate as carriers perceive the manufacturer as cutting corners. The reputation damage proves irreversible. Flight 191 wasn't the DC-10's only 1979 disaster. Just 5 months later, Western Airlines Flight 2605 approached Mexico City International Airport through dense fog. Due to a communications breakdown, the DC-10 landed on a closed runway, undergoing maintenance work, striking construction vehicles, and bursting into flames. 72 people died in what became Mexico's deadliest aviation accident at the time. This wasn't design flaw. It was pilot error and poor communication. But for a public already suspicious of the DC-10, it didn't matter. 3 fatal DC-10 accidents in 1 year created a narrative of a cursed aircraft that transcended rational analysis. The pattern had started earlier. In 1973, just months after the first cargo door incident, National Airlines Flight 27 experienced an uncontained engine failure at cruising altitude. Engine debris shattered a cabin window, and 1 passenger was explosively decompressed and killed. Each incident, regardless of cause, reinforced the growing perception that the DC-10 was dangerous. Aviation experts understood the distinction between design flaws and operational accidents. But the traveling public saw only a deadly pattern. The media amplified this narrative. Every DC-10 incident received disproportionate coverage compared to similar accidents involving other aircraft types. McDonnell Douglas found themselves fighting not just technical problems, but a public relations war they couldn't win. Remember ETOPS, the regulation that made 3 engines essential? It's evolving rapidly. New technology has allowed twin-engine aircraft to fly increasingly long routes over oceans. The DC-10's third engine, once its greatest advantage, becomes an expensive liability. Modern twins prove more fuel-efficient and reliable. Boeing 767, introduced in 1982, captures the market the DC-10 was designed to dominate. Later, the 777 became everything the DC-10 promised to be: efficient, reliable, and trusted by passengers. The trijet market doesn't just decline, it collapses. Lockheed, already reeling from weak L-1011 sales and troubled engines, announces its exit from commercial aviation altogether. The TriStar proved that even brilliant engineering couldn't overcome poor timing and limited demand. Alongside the DC-10, it defined both the rise and fall of the trijet era, a technological dead end swept aside by the twin-engine revolution. By 1984, production comes to a halt, and McDonnell Douglas, still wrestling with technical problems, now faces a larger truth. They're fighting not just competitors, but a revolution they cannot win. In a desperate attempt to salvage their commercial aviation division, they launched the MD-11 in 1990. It's essentially a stretched, modernized DC-10 with updated avionics, but it arrives too late and underperforms fuel efficiency promises. Even worse, airlines worry that passengers will see it as simply a stretched DC-10 and avoid booking. Modern twins like the Airbus A330 and Boeing 777 offer better fuel economy, lower maintenance costs, and the operational flexibility that the ETOPS evolution provides. The trijet era ends not with celebration, but with quiet obsolescence. Like the TriStar, the DC-10 found unexpected salvation in second lives outside passenger service. FedEx discovered something interesting about the DC-10. Remember that unusually large cargo hold designed to compete with passenger aircraft? It makes the DC-10 perfect for freight service. Away from public scrutiny, the aircraft's reliability improves dramatically. FedEx eventually operates over 60 DC-10 freighters, becoming the type's largest operator. UPS follows suit, converting passenger DC-10s for cargo operations. In freight service, the DC-10 finally fulfills some of its original promise, just not in the role anyone expected. But for McDonnell Douglas, redemption comes too late. Weakened by the DC-10's commercial failure and unable to compete with Boeing and Airbus in new aircraft development, the company merged with Boeing in 1997. The merger effectively ends Douglas's 76-year history as an independent manufacturer. It leaves Boeing as America's sole large commercial aircraft producer for decades. The last passenger DC-10 retired from service in 2014 with BIM Bangladesh Airlines. FedEx operated the final DC-10 cargo flights in 2021, ending exactly 50 years of operational service. A few survive as aerial firefighting tankers, their powerful engines finding one final purpose, battling wildfires. But the DC-10's most important legacy, it isn't in cargo holds or fire suppression. It's in the fundamental transformation of aviation safety. Dan Applegate's ignored memo became required reading in engineering schools worldwide. It teaches the critical importance of listening to safety concerns regardless of commercial pressure. Aircraft certification became exponentially more rigorous, and that might be the most important legacy any aircraft could leave behind. Before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?